We now have an understanding of what the blockchain is: a decentralized and distributed ledger that is publicly shared across the nodes of its network. Now let's go into the blockchain in practice and discover the use cases for blockchain technology. The first use case you will often hear people bring up is a cryptocurrency. Blockchain technology and cryptocurrencies so frequently appear in the same sentence that the concepts have almost become synonymous in tech culture. So cryptocurrencies do leverage the blockchain, but a cryptocurrency is its own technology that only has the blockchain as one piece in its puzzle. A cryptocurrency itself is a digital medium of exchange. It has three main aspects. First, indeed a secure blockchain. Then it has cryptocurrency wallets. And then it also has the concept of mining. For the first aspect, the cryptocurrency leverages the blockchain. It does so in order to keep a public database of transactions that everyone has access to. One question, though, is if everyone has public access to this database, couldn't someone modify the data in order to manipulate the system and transfer more currency to themselves? Well, to prevent this problem, as part of the solution, a cryptocurrency uses cryptography to add a layer of security to the blockchain. With cryptography, the blockchain uses a technique of using algorithms to obscure data into hidden, or in other words, cryptic messages, which gives the blockchain the ability to generate digital signatures for individuals in the network. So these digital signatures are like unique handwritten signatures, but with far more inherent security, as it solves the problem of impersonation and tampering. So in practice, each individual who wants to record a transaction in the blockchain must stamp the transactional data with the unique digital signature. So how do these signatures work? Well, each individual signature is based on two keys: a private key and a public key. These keys are a string of numbers. So one key is a private key that only the one individual has access to. The other key is a public key that everyone can see in order to identify the individual. With these keys then, the user has the ability to sign data, such as transactional data. The individual creates a signature that is an encrypted hash value. The hash value is generated by a combination of the data and the private key of the individual. So since the value of the hash is based on the original data, any change to that original data, such as just changing one character value, will generate a new hash signature. And now that the data has a signature, anyone can use the same derived public key of the individual to verify that signature. The public key is used to decrypt that signature and then read the original data behind it. So in the event that this decrypted data does not match the original data presented by the transaction, we know that one of two events have happened. Well, the original data was tampered or altered corruptly, since the data that was signed does not match what was decrypted from the signature using the signer's public key. Or, on the other hand, the signature was generated with a private key that does not correspond with the public key that is presented by the person who is doing the transaction. So overall, the system with the private key and public key pair to generate signatures on data adds a highly secure system of integrity as well as authentication to the blockchain-based cryptocurrency. This brings us to the second aspect of cryptocurrencies: wallets. Wallets are objects that store the private key and the public key of an individual in the network. Like a physical wallet, they can also help you track how much cryptocurrency is entitled to you. Your public key is used as an address for your wallet, and that is what other individuals use to send cryptocurrency to you. And by utilizing the stored private key, the wallets are used to help generate the signatures that sign transactional data. For our final and third aspect of cryptocurrencies, we have mining, which we'll explore in more detail next.